In our second video today, we will understand algorithm from another angle. So 8.2, description of an algorithm. All right. The second topic, we want to describe an algorithm. Okay. Yeah. So our goal, find a solution for a computing problem. Yeah. How to find it? Okay. So to find a solution, this time we, for the continuation of the previous video, remember, we need to develop a step-by-step procedure, to solve the problem, right? Yeah. So we need a precisely defined procedure to get that solution. Okay. Yes. All right. What kind of step-by-step procedure, right? What kind of it? Yeah. So we want to see that a little more. Yeah. So we need to look at the implementation details. Step by step. Yeah. Here, there is a simple diagram. So usually we describe the step-by-step procedure using, this kind of diagram or flowchart. Okay. Yeah. To give us some overall view of the whole solution. Yeah. So that's the design part. So we use this diagram for our design. Okay, algorithm design. Yeah. In this level, a lot of details are missing. So we do not need to provide all the details. Yeah. We just want to get an overall idea on the solution, for the solution. Okay, yeah. Then each step can be represented in code. So eventually we need to write our code to implement those steps and solve the problem. So when you design those steps, you need to make sure each step can be represented in code. Yeah. Okay, yeah. After that, then at the end, you need to write the code. You need to create that computer program to produce the answer. Yeah, something like this. Okay? Yeah. Do a lot of work, debugging, experiments, failure, successful. At the end, you solve the problem. Okay? Yeah. So try to imagine that procedure. Yeah. All right. So with that, now we try to answer this question. What is an algorithm? Okay. Yeah. Now we describe it from several aspects. Okay. Yeah. First, it is a sequence of instructions. Okay. And those instructions should be unambiguous. So very clear. They could be implemented by a computer programmer, a qualified computer programmer, right? Yeah. So that's one aspect. Another, if we look at the input should satisfy some condition. Okay? Should be legitimate. Data should be valid, right? Data should be valid. Our input data. So usually we need to provide a validation step to validate our data. Okay? Yeah. So after that, we do data processing, right? Produce solution, right? And the solution will be reflected as output. Okay? So the output should satisfy some condition, satisfy the required format. Yeah. Think about a typical real-world situation. Yeah. Suppose Your company, you need to provide a solution for a real-world computing problem for your customers. Your customers, they want certain type of output result. Okay? So then you need to make the output satisfy the required format that your customers want. Right? Yeah. Right. Then, after all those conditions are satisfied, another aspect also very important: execution time of your algorithm. And this aspect is extremely important, is a main consideration in this class. Execution time. Okay? First, it must be finite amount, right? The algorithm can terminate. Okay? Yeah. So not, running forever, can never generate output. That's useless, right? So the lowest requirement, the minimum requirement, finite amount for the execution time. But that's still not good enough. Right? The response time should be acceptable to your users, your customers, acceptable. If it is too slow, so your customers do not like this kind of performance, then we cannot deliver a good solution, right? Yeah. So you can imagine this factor, the performance. Yeah. All right. We want to make our algorithm as fast as possible. So we will see that. Now, the same computing problem, we use two different algorithms to solve. One very slow, one very fast. How much is the difference? So we will compare. In our next part B, we will see that. Huge difference. We will see that. Huge difference. Yeah. All right. Next, how to get an algorithm. Yeah. All right. We know it's important. Yeah. Suppose at this point, we all know algorithms are very important in our problem solving. But the question is, how to get an algorithm? So in this class, we will learn the details. We will learn how to get it. Okay? Yeah, a lot of details. Yeah. But the most important thing to develop a good algorithm, that's thinking. Thinking. Yeah. So we need to use our biggest asset, brain, to do some valuable thinking, a lot of logical reasoning steps. Okay, yeah. When we design algorithms. Yeah. All right. How important is thinking in problem solving? We know, very important, right? Yeah, how important? Yeah. Here, I like to use some interesting story to understand this part. Although we all know it is very important, but we like to see, we want to get some concrete impression for this issue. Okay, all right. Here, I like to use a interesting AI story. So this picture, so you can connect to AI, artificial intelligence, machine intelligence, right? Yeah, yeah. Machine try to do some very intelligent problem solving, similar to our human can do, even better than what we can do. Yeah, that's AI. Yeah. So why we use an AI story here? Yeah. The reason is very simple. Yeah. Because first, it is an exciting story, AI. Yeah. Remember in the previous video, I used that, chess AI program, Gary Kasparov. Here, I like to use another recent exciting story to, explain this understanding. Okay, all right. AI means algorithms. The reason we talk about AI, because the most important part in AI, that's algorithms. So we use AI to help us understand why algorithms are so important in our problem solving. All right. So here, AI, we can write this way: AI equals algorithms. We can even write as simple as this equation, right? But actually, more precisely, AI means an advanced algorithm. Okay, not just the simple algorithms. An advanced. So very smart, very intelligent algorithms. All right. So actually, what does AI do? Simulate human thinking. Simulate human thinking. So here, this picture, you can see, that's the human thinking simulation. Okay? Machine, trying to simulate human thinking. Okay? In some special way. Okay? What kind of special ways? Based on specific algorithms. All right. The example I like to use, AI Go game. Go game. So you may not be very familiar with the Go game, right? So it is an ancient Chinese board game. Ancient. How ancient? More than 2,500 years ago. Years. That old. So very old. All right. So the reason I use this example, because this Go game is extremely complicated. Computation-wise, if we look at the complexity in computation, because if we want to use AI to do the Go games, then we need to translate it into a computation problem. The complexity of that computation problem, extremely complicated. How complicated? So here, let me describe the complexity, comparing the Go game with the chess game. We know the chess game is already very complicated, right? But if you compare it with the Go game, much, much more complicated than the chess game. So what do we mean more complicated? Here we need to use some simple criteria to compare. All right, Go versus chess. What criteria do we use? Legal board positions. Legal board positions. So we count how many legal board positions. We know for a board game, there are many positions that are not legal, right? Many positions, they're not legal. Okay, so we need to eliminate all those illegal board positions for the board game. Okay, all right. After that, then we do the comparisons. So some numbers here. For chess, this many, 10 to the 43rd power, this many legal board positions. So you can imagine it is a huge number, right? But if we look at the Go game, that number is much, much bigger. 2 times 10 to the 170th power. That big. So look at the difference, huge difference. So you can imagine. So when we see the representations like this. We know they are both huge numbers, but how big are they? It's hard to get a sense on it. It is very hard to get any sense on it. Yeah? But for a comparison, I want to use another reference big number so then you can compare to get a little more sense. So what's that? Think about the number of atoms in the observable universe. Universe, huge, right? In the whole universe. Think about the number of atoms. Atoms, each atom very small, right? Yeah, so there should be a huge big number atoms in the observable universe. What's that number? Yeah, scientists estimate that number, this many, 10 to the 80th power. 10 to the 80th power. See? So you can see this number is somewhere between those two big numbers. Okay? The number of legal positions for the Go game, much, much bigger than the number of atoms in observable universe. To handle that many different positions, how powerful a computer program, algorithm should be. So you can imagine that, right? Yeah, all right. Next, we want to see some result, right? Yeah, so after this kind of comparison, description, one milestone. Yeah. AI beat human champion. Which year? Yeah, this year. In year 2016. Yeah, March 2016. Yeah. So this picture gives you that story. Okay? Yeah. All right, so that AI game is called AlphaGo from Google. Here you can see the Google. So they bought a small company called DeepMind. Yeah. Here. So it is a British company, DeepMind. Okay. Deep, see, from the name you can imagine, yeah, because the IBM program, AI chess program called Deep Blue, right? Deep Thought. IBM, they created two AI programs. The first version called Deep Blue. Second program, 1997, Deep Thought. Right? Yeah, deep something, right? So that word. And this company called DeepMind. Okay? Yeah. So Google bought that company. So then Google put a huge resource there. So then they produce a very powerful AI system. Yeah. All right. Now the result. Compete with human champion. This human champion, his name is Lee Sedol from South Korea. Okay. Yeah. He won 14 world champions at that time. 14 world champions at that time. Yeah. He's a genius. Yeah. He's a legend of South Korea. Yeah. All right. So this player, human player, represent human. Yeah. Our human. Compete with AI. Yeah. Now the result. So not very good for human. Yeah. Okay. Play 5 games for $1 million prize. 5 games. Okay. And the end game. Yeah. Each game lasts 5 hours. Yeah. So real tough games. 5 hours. Okay, yeah. Each one. The results 4-1. AlphaGo beat Lisa Do 4-1. Yeah. The result is this. Okay. The first one, AlphaGo was white. White won. The second one, the AlphaGo is black. Black won. Okay. The third one, AlphaGo was white. White won. All right. Yeah. The fourth game, AlphaGo was black. White won. Yeah. So Lisa Do won the fourth game. Okay. Then the last game, AlphaGo was white, and AlphaGo won. Okay. So 4-1. Yeah. But actually, I watched all 5 games. I was a big fan of Go. Yeah. I watched all 5 games because that was a big event, huge event in human history. So I watched those total 25 hours, right? 5 games, each game 5 hours, 5 times 5, total 25 hours. Okay, spread in whole week, 1 week period. Okay, yeah. So I watched those games, try to understand the power of AI. Okay, yeah. And although 4-1, the game won by Lisa Do, not convincing game. Actually, it was give out of AlphaGo. AlphaGo basically just gave it away to Lisa Do. AlphaGo played several consecutive horrible moves. Very stupid, horrible moves. Just like suicide in a Go game. Suicide. Yeah. So the professional Go players, they will never play that kind of stupid moves. Yeah. So I treat AlphaGo basically just gave that game away to Lisa Do. Yeah. So that's my opinion. Yeah. My opinion. All right. Yeah. But because the later another story proved this explanation, prove this view. Okay. Because soon after that, just a few months, a little more than half a year. Yeah. Because this happened in March. Then in December the same year. Okay, yeah, 9 months. A person 9 months. The second version of AlphaGo came out and challenged the top human players, human Go players, top level human Go players challenge in the world. Yeah. So the result is like this. The newer version of AlphaGo called Master. Okay, Master. So they changed the name of AlphaGo because they want to hide it. Okay, so when they compete with human Go players, they want to hide the AlphaGo background. Okay, yeah. So then challenge human Go players, professional human Go players. The result 60-0. 60. Okay. Never miss anyone. So you can imagine that one. So basically just, give it out. Yeah. If the master, the AI Go program is serious, then human cannot even win 1 game. No chance. 0 chance. So you can see that huge difference. Right? That huge difference. Yeah. All right. So the algorithm, the detailed algorithm. So the Google DeepMind team, 15 something, approximately 15 members, of that team. So they wrote a very important paper and published in Nature. Nature. Yeah. So everybody, can study that paper and implement the algorithms. After that, many countries, China, South Korea, Japan, so those countries, each country, they have several teams implement their algorithms. Although they, modify, put their own ideas, all three countries, they produced very powerful AI programs that can beat human champions easily after that. Okay? Yeah. All right. So now you can see algorithms could be very powerful. Yeah. Okay? Yeah. And this AI game, the successful story behind this AI algorithm, deep learning. Yeah. So you may heard of that, deep learning all the time. Okay? Yeah. But in this class, we will not touch deep learning topic. Yeah. This class, we just learn the basics, the foundations of algorithms. After you get this kind of foundation, then you are ready to go to the next level, higher level, and you can learn deep learning and many other advanced topics. Yeah. All right, so let me stop here for my second video.